Hello, my name is Ramin Hujjati, and today I will be giving an introduction to property verification using a simple design and a simple property. I'll be using the tool Solidify from Averant. My simple design is an up-down counter, and it has the following control signals: UD. When UD is on, the counter counts up. When UD is 0, the counter counts down. Load, when the load is on, the value of the data input CN is latched into the counter, and EN for enable, and this signal enables the counting. Let me show you the Verilog for this design. And here we go. And you could see that we have the inputs I mentioned, we have the output, we have a combinational logic block that computes the value, the next value of the counter, and then we have a sequential block which latches in the next value into the counter. So in order to do any kind of verification in Solidify, you need to create a design, and we're going to use Solidify's GUI to do that. So we bring it up by typing Solidify client, and here's the splash screen. And I'll use Solidify's create project GUI to do that. There are other ways of doing it. There are 3 fields I need to specify: the name of the project, which I'll call UD counter, the location of the project files, and then a work directory. So let me specify them, and let me add my design files. And what Solidify now does is that it creates the project files, which are these 2 files, .des and .unt. And since I've been working on this demo for a while, I also have a bunch of files in my work directory that you can see. Generally, there will be lots of files in here. Okay, the next step in this process is either computing or specifying a reset sequence. For computing it, Solidify does it automatically in compilation, and that's generally how this is done. So you go under Tools, Compile, and you hit Compile, and you could see that a reset sequence has been computed. We're now ready to work on our property. Our property is simple. It's over 2 cycles. In the first cycle, we set up the property. In the second cycle, we check that the correct behavior happened. The setup is that if UD is 1, and if we're not loading the counter, then the counter will increment in the next cycle. Notice that load has priority over counting, so we have to turn off load when we're checking that the counter is correctly counting up. We're going to be using the SVA language for this. We're going to use kind of a smaller version of SVA than is typically used for this purposes, so that we can get going quickly. In SVA, we need to wrap everything with a module and module pair. We need to wrap our property using assert property and parentheses. And then we need 2 constructs. The first construct that we need is called a next implication operator. And what it means is that if the left-hand side is true, then at the end of it and in the next cycle, the right-hand side should be true. So we take the left-hand side, which in this case is just combinational. There's not a sequence. And then we go to the end of it, which is just 1 cycle. And then we advance time. And then we look back to see if the current value is the same as the previous value plus 1. And to look back, we use $past function. So we'll show these concepts. We'll create our SVA property. Let's give us some room here, and we will start off by specifying module counter and end module. Then we say assert property, and then we have parentheses in there. And let's start off by saying that if UD is on and load is off, then we advance time, and then we check that the value of counter in T1 is equal to whatever value it had in the previous cycle plus 1. We hit Control S to save this, and I believe we are ready for verification. All right, we'll see that we get a debug trace, and the first signal in this debug trace is one created by Solidify, and it tells us where the property fails, and it fails in T1. And we could see the counter never counts up even though the UD signal is on, and we immediately notice that it's because the reset signal is also on, and we don't want the reset signal to be on. And there are multiple ways of preventing that, but we'll do a simple one, which is we'll just write not reset inside the property. And we'll save it and hit auto verify again. And again, we get a debug trace. We notice that the counter is again 0. We notice that reset is behaving correctly. And UD is behaving correctly as well. But we notice that enable is off. And in order for the counter to count up, enable has to be on. So we go back and we add the constraint that enable has to be on, save it, and verify it again. And this time it passes. So if you were working on a more complex property, there's a few other things that you need. In order to turn off reset, generally you would use a construct called disable, if and only if. And the way that goes is that you take the property and you put disable if and only if in front of it, and then you give the reset signal in it. Also, you generally need to specify the inputs to the SVA module. You generally need to bind the SVA module to the design module. You generally need to put the SVA files as part of the design files. That's because SVA generally contains some monitoring logic, and in order to be compiled, we need to combine it with the design. And you generally need to also specify a clock for the property. In this case, since the design is single clock and single edge, the property time and the design clock coincide. That concludes my simple demonstration of a simple property. Thank you.